All right, friends, welcome back. We're going to talk about solving for exponents using logs. This is the one that I've been dying to get to because what are logarithms? Well, remember, I've shown you a couple of different times things like this. 3 to the x power equals 9. If you look at that, you're like, oh, hey, I know that 3 to the second power equals 9. So that must mean that x equals 2, right? So x equals 2. If I give you 3 to the x power equals 10, no good. That's not a friendly number. We're not going to be able to choose a nice, pretty integer in order to give us an x here, or to give us 3 to the x power equals 10. There's no pretty integer that's going to give us a 10. So what we have to do are use logarithms. And now we're going to talk about how we do that. Before we go on, and I started to explain it right here, this versus this. So you're going to want to make sure that you have this down. Log base A of B equals C, and which becomes A to the C power equals B by using that snail method, right? And then our change of base formula, we're going to go into this more in depth in another lesson, but I just want you to write that down. Log base A of B equals this guy right here. Okay, so let's start with an example. We have 6 to the x power equals 28. The first thing you want to ask yourself, is 28 a friendly number? Can I get it to a base 6? Sure we cannot. We can do 6, we can do 36, things like that, but we can't do 28. So what we're going to have to do is put this into logarithmic form. And in order for us to do that, remember, we have AC to the C power equals B. We're going to put it into logarithm form like this. This is how I remember it. You take the outer two, this, and smash them together. Log base 6 of 28 equals x. Now, always double check it by using your snail. If I did this, I would get 6 to the x power equals 28, which is what I started with, so I have done this correctly. Now, the change of base formula, log base 6, all your calculators do are log base 10, and so if you have a log base 6, that's not going to really help you on your calculator. Some calculators will do a different base, but most do not. So let's assume your calculator does not. The way that we have to enter this into our calculator in order to figure it out is going to be like this. We say log 28, because we pick the big number, meaning the physically larger number, not the numerically larger number, divided by log 6 equals x. These two things are the same. Log base 6 of 28 is the same as log base 10, because remember, if it's not shown, it's 10, of 28 divided by log base 10 of 6. Okay, so how do we enter that onto our calculator? If we have log 28 divided by log 6, you end up with this big old long number. Oops, I didn't realize my light was reflecting in there. Sorry about that. So you get this big number here, which is x equals 1.859738 ... so on and so forth. Now, the more decimals you keep, the more accurate your number is going to be. So usually you want to keep about 4 decimal places. So if I want to round to 1, 2, 3, 4 to here, am I going to keep that as a 7 or bump it up to an 8? I'm going to go ahead and keep that as a 7 because the number next to it is less than 5. So x equals 1.8597. Now, let's go back and check that. If I were to plug that in for this x right here, 6 to the 1.8597. So 6, let's see if I can get that. There we go. 6 to the 1.8597 power. Kind of hard to see. Sorry about that, guys. You end up with this 27.99805. That's because we're rounding and estimating here. It's an irrational number. It's a number that goes on forever and doesn't repeat. But that's really 27.998 is really close to 28. So the more decimals you have at the end, the more accurate your answer is going to be. All right, so let's try that again. Remember, the easiest way to do this is take these outer two and smash them together. So log 1.8 of 96 equals x, and now we have to do our change of base formula. So we say log 9.6, my apologies, divided by log 1.8 equals x. So you always put this number on the top, and then you put your base, this number, on the bottom. Again, let's type that in there. So if we've got log 9.6 divided by log 1.8, we end up with okay, so x equals 3.8479, and I'm going to leave it as a 9 because the number next to it is less than 5. All right, so you have just solved some exponents, or some logarithmic equations, looking for exponents that are not nice, pretty numbers, right? Not nice, pretty integers. Okay, so let's see. All right, so sometimes these get harder. So let's try a harder one because that makes me excited. Let's do this. Okay, so if we've got this guy right here, whew, this looks like a doozy, right? The reason you know you're going to be using your logarithm is because if you have your variable up in your exponent and you see that that x is up in the exponent. So either we're going to have to find common bases, and you're looking at this and you think, oh, well, this and this are close to common bases, right? Let's first isolate the base that is attached to our variable here. And then we can see, can we use common bases? And if we cannot, we're going to have to use logarithms to solve this. So the first thing I want to do to isolate, and what I'm trying to isolate is this thing right here, right? So to isolate that, I'm going to minus 1 from both sides. And I don't like that pen, so we're going to use purple. So now I have 1/3 6 to the negative 4 over x power equals 4. Oops, let's see if I can count. It actually equals 5. 6 minus 1 is 5. Now, I again want to get this chunk by itself. So I'm multiplying by 1/3, but we never, and the opposite of multiply is divide, but we never divide fractions. Instead, we multiply by the reciprocal because those cancel out. So multiplying by 3 on that side, I got to multiply by 3 over here. So now I have 6 to the negative 4 x power, 4 times x power equals, and in this case, it's going to be 15, 5 times 3. All right, do I have common bases there? Sure don't, and I'm not going to be able to get them. So this is a good time, now that I've isolated my base here, to use our logarithms. Remember, logarithms, we take the outer 2 and smash them together. Log base 6 of 15 equals negative 4 times x. Now, if I were to use my snail, you'll see, whoops, I really don't like that pen, do I? You'll see that I would get 6 to the negative 4x power equals 15, and that's what we started with, so we've done that correctly. Okay, so let's see about finding a pen that works. Okay, so now that I have it set up like this, remember, I can't do a base 6 in my calculator. I can only do base 10, so I'm going to say log 15 over log 6 equals negative 4 times x. The opposite of negative 4, or not, the opposite of multiplying negative 4 times x is dividing. So I'm going to divide by negative 4 and divide by negative 4. So x equals log 15 divided by log 6, and whatever that garbage is, we're going to divide it all by negative 4. So this is what we enter into our calculator. Log 15 divided by log 6 gives me 1.5139, blah blah blah. You don't want to simplify now or round now, because remember, we need to divide by negative 4. So if I divide by negative 4, you see that I end up with that number. I want to go to the 4th decimal place, which is 8. The number next to it is 4, so we're going to leave it as 8. So x is, and you can use the little approximately symbols to show you that you're estimating it, negative 0.3778. And sure enough, if we were to plug that number into here, 6 to that power, and then we would multiply that by 1/3 and add 1, we would get a number that's very, very close to 6. So maybe like 5.99 something. So hopefully this helps. If you have any questions, let your teacher know. Otherwise, we will see you next time.